Hello Internet, this is Ulrich and welcome to 2021. Yes, you made it. So I hope you're as excited as I am to see what the new year will bring us especially in the world of tech. If you're planning to upgrade your studio this year with 10 gigabit link capabilities, this video is for you. This is the second part of the series. In the first episode we talk about new Synology 10 gigabit card with NVMe caching capabilities, which is E10 M20 T1 card. If you are interested to see how this card is set up, the video for you is over here. In this episode we're going to talk about actual connectivity. So the second key element for my setup here is CalDigit 10 gigabit Thunderbolt 3 adapter, which we are using to connect my MacBook Pro to 10 gigabit link to the NAS over the Cat 7 cable. So if your MacBook is limited on internal disk capacity, offloading some of the files to external storage is the way. And as your data library will grow up in size, offloading it to RAID protected storage array is the preferred method to keep your data both safe, available, and also protected. The key word for this video is a speed test. We're gonna do a lot of speed testing using different applications, including BlackMagic, IOZONE, and FIO, to measure the throughput and access speeds for this particular setups. If you're here, however, for technical details and would like to jump directly to the speed results, there's a time code listed in the description down below. You can use that to navigate around this video back and forth. So the baseline for our setup would be my Akitio setup, which I have for many years, and this is Thunderbolt 2 base storage with RAID 5 configured disk array of 4 Samsung SSDs, and expected throughput for this setup is around 900 megabytes per second. However, if you set up your Akitio as a RAID 0, you can expect advertised speeds of 1375 megabytes per second, which is a lot. The detailed video of how I set up my Akitio and how I test my performance is available for you right here also. So I suggest you watch that if you're interested to have that setup. With the Thunderbolt 2 base storage array, but there are Thunderbolt 3 models from Akitio available as well. You can buy them right now on Amazon. Connect to Akitio from my MacBook Pro 16-inch. I'm using adapter Thunderbolt 2 to Thunderbolt 3, which is two-way bi-directional adapter. As you know, Thunderbolt 2 supports speeds up to 20 gigabit per second. Thunderbolt 3, however, supports speeds up to 40 gigabit per second. We're gonna test 10 gig link. The speeds we expect to be less, but we'll see how much less it's going to be. The second test, I'm using different setup, which is 10 gigabit link connected from my MacBook Pro to my Synology DS1819, but the pool on the Synology is RAID 5 based pool of 4 SSDs. Again, similar to setup which I have in Akitio, but this time around we're going to connect using 10 gigabit link from my MacBook Pro to the Synology DS1819 Plus, and that's going to be pure test for the link itself. We're not going to engage NVMe cache because cache is configured on different pool. And the final one is going to be the testing which we're going to do on my target setup, which I'm planning to use, and that is going to be my connection between MacBook Pro to 10 gigabit link to Synology NAS through the NVMe cache on that 10 gigabit card to the pool of RAID 5 Iron Wolf disks, which are 8 terabyte disks. Currently I have only 3 configured in RAID 5, but I'm planning to expand it at least with 1 more disk very soon. The application for all this exercise is my workflow with FinalCut Pro. So the FinalCut is using large data blocks to move data back and forth. So for IO testing, we're going to be using 64K block sizes and with the target files generated of 5 gigabyte in size. So I'm going to be using multiple threads. So for IOZONE, we're going to be using 16. For FIO, we're going to be using 8. Why 8? Because currently FIO version for macOS, which you can install using Homebrew. If you're interested to see how it's done, let me know in the comments in the description down below, and I will answer your questions. But the FIO right now is only using 8 threads, which is maximum for macOS version. So why it's gonna be between 8 and 16? Well, my setup for MacBook Pro is based on Intel i9 8-core CPU. So the idea here is to try to potentially use one single thread for each data stream for the data going through the disks. Alright, so let's the fun begin. So let's open it up. The box is pretty small. As you can see, there is an adapter right here, 10 gig, CalDigit, all the attributes. So let's open this thing up. So as usual, there is a thank you card, there is some instructions, quick start guide, stuff like that, and here's our adapter itself. This is, whoa, that's heavy. That's what it is. As you can see, that's our 10 gig connection, and this thing is USB-C connection, so there is nothing else. Thunderbolt 3 right there. Small CalDigit Thunderbolt 3 cable. It is connected right now. Very simple connection. Thunderbolt 3 to the CalDigit itself, and then from here to 10 gig network. Now it's only time to connect it and configure it on the Mac OS, and I'm going to show you how it's done. Alright, so for MacBook Pro we will need to set up some IP addresses on Thunderbolt adapter. As you can see, I'm setting up my IP address here. 10 subnet is recognizable for me for 10 gig network. You have to specify your subnet mask and your router, which would be default for the actual IP address of the Synology, and make sure you check and change to standard MTU to jumbo frames. That's very important. And go to network interfaces with user network LAN 5 and make sure you have following set up. So you have your IP address, you have your subnet mask, and you have to select jumbo frames MTU size change to 9000. So you got that, got edit, and this is how it's done. Set up manually MTU, get it to 9000, and this is the IP address. As DNS server you probably want to skip, doesn't really matter because this is directly connected. But the rest of it has to be set up. Also, on the MacBook Pro side, you specify your gateway as a default IP address for this guy. So for MacBook Pro, gateway would be IP address of the part on the Synology. Alright, so also what you have to do also for file services, make sure you have SMB set up correctly. So SMB services. So just go over here and specify maximum protocol SMB3, and minimum is SMB2 with large MTU. So this is expected as well. This way the performance will be optimized, otherwise it's not going to be the fastest. Let's go and connect. So make sure you don't have any VLAN set up on your Synology for direct connection to your Mac. So we're going to go connect server, and we're going to go SMB 1021, and we're going to connect first to fast space, and here it is. So now what I'm going to do is to run my test against this fast space connection. Alright, let's go select the drive, target drive, and we're going to say that it's going to be our 1021 fast space temp. Open up and start. So we're talking about 485 megasecond and 807 on read, which is pretty close to what I expect. 902 megabit per second change to 4 gig. Start again. Yeah, that would be on the SSDs, so 719 and 460. So what I can do here, I can do my video editing up to here, 2K. I can do pretty much everything for 2K. Okay, for ProRes 422, I can do pretty much all of it. So let's go back and change drives to the one which is on Iron Wolves. And let's go to vlog data, temp, open it up, and the speed will go with 1 gig. Let's see, 442, and pretty much identical. So it doesn't matter if it is SSDs or is it on the actual drives. The speeds are pretty identical, probably primarily because of the cache. So these are very good speeds, so this will allow me to edit directly off the actual disk. So what we're gonna do, we're gonna do 2 IO based tests. One of them is FIO and the other one is IOZONE, and we'll go against our ideal layout, which is Work 4K, which is my Akitio box, which I'm using on a daily basis to work with footage for Final Cut. And we will go with 10 gig connected Synology pool of SSDs, and also 10 gig connected Synology pool of normal Iron Wolf drives. And our baseline, of course, is Work 4K location on Akitio, because this is the fastest. It's connected through Thunderbolt 2, and it's rate of 4 SSD drives, which are Samsung 512 gig drives, configured in RAID 5 configuration. So here we go. This is my location for Work 4K for temp IOZONE. So I'm going to just recall my IOZONE command. So I'm going to go with 64K blocks, and we're going to create 16 threads because this MacBook Pro got 16 threads. And we're going to build files with 5 gig, and the option here say that I'm going to delete the files once they're created. Alright, so let's go do that. And IOZONE is going. It's not very interactive because it's creating the files right now, but it's going to show results at the end. Versus FileTest. FileTest will show you all the data as it's going, and it's give you summary at the end. So we expect pretty high throughput on the Akitio box from the IOS perspective and from megabit per second perspective, and maybe even on the side from the disk side over here from the testing, we can see that it's doing actually 1.35 gigabyte per second writing right now, which is very impressive. This is more than enough to produce and operate on 4K based footage. So ideally, with Final Cut, we're working on the big blocks of data. So 64K, that's why I selected 64K blocks for the test. And to scrub without any pain over Final Cut timeline, you would need speed around 250 megabit per second at least, to make sure that you have no delays or no skip frames or no drop frames. 941 on individual threads. Here we go. 941, and initial writing as well is 941. Okay, this is ideal, even though the Apple monitor shows you the actual speed of 1.5 gigabyte per second. But let's see how it's gonna go on the different side. Let's go to SSD on the 10 gig connection on Synology. Alright, so here I have test running, and you see on the background SSD pool does not have cache associated with it. But here is the speed on the Synology side, 403 and 18. It's dropping, but it's going up and down. And surprisingly enough, we're using only main cores.
A few moments later,
the actual speeds reported on the zone test itself, plus on the Synology monitor. But as you can see here is 551, which is not bad at all for the SSD. And again, this is just RAID 5 build of 4 SSDs. And now let's do the same test for the spinning drives, which is Iron Wolf. Same test again. Yeah, these are the drives. So we're actively talking about 2 drives being engaged all the time, and drive number 3 is used for parity. So if we go to the actual calculator over here, that would mean that, as you can see, if I have only 3 drives in the group, I should expect something like 250 megabyte per second speed on that RAID array. And that's pretty much what we're gonna get. But that's gonna be not enough for the direct day-to-day work with Final Cut, because for Final Cut we would need at least 300. And to get 300, I would need to add 1 more drive here. And that would give us proper speed 336, which is above 300, which is going to be good. And again, I'm going to bring back my monitor. And right now the cache is actually being used. If you go to SSD cache, you see it's being used right now. 274, yeah, that's what we would expect. Around 250, 270, maybe occasionally 300, but not much. IOZONE test and FIO binaries are not native for iOS, so you have to install Homebrew over here first in order to get these binaries running. If you're interested to know how to do it, I can put instructions and answer you comments in the comment section down below how I did that.
A few moments later.
Alright, and here are the results. Like I said, we're talking about 236 megabyte per second speeds. Well, that's expected, is way in alignment with what we expect on that array. The only hope was that cache, which is used on this particular pool, would speed things up, and this is fast cache with NVMe drives. But it looks like it's not using it much, it's just going directly to the actual drives behind the pool. So let's see with FIO. FIO is slightly different algorithm, so we'll give you an idea. The numbers should be pretty much identical, but it's a different method how to measure the IOPS. Yeah, the speed is around, for writing, is 930 megabyte per second. And we're doing almost 15K IOPS. Yeah, as you can see here, FIO test reports 1.2, and that's pretty much identical to what reported by the activity monitor. Now it's dropping and it's going to increase again. So the results which we have is, on average, we're writing around 785 megabyte per second. The FIO test usually reports also usage and utilization of the disks, but for the macOS version, it doesn't have that data. So you can see, you can get minimum IOPS, maximum IOPS, all the other stuff, which is reported here, but there is no utilization on the disks, similar to what you would see if you run similar test on Linux, for example. Alright, so let's go back and just go and run test against SSD drives.
A few moments later.
And alright, so what we got? We got 504, 528 maximum, and number of IOPS 8K. Maximum again 13K, but average is 8K. So it's slightly less than what you would have on Akitio. Alright, and now the final test is on Ironwool drives. And we immediately see the drop in the performance. So we're only doing around 185, 200 again. Like Apple monitor reports 222, but the jobs on the FIO test reports around 222, 198 as well. Much less than that would you expect to work without any interruption on the FinalCut. So you would need that faster. And IOPS is only like 3K. Okay, and here is the results. 189 megabit, 199 maximum, 200 roughly, right? Maximum IOPS is 16K, but average is only 3.7, which is not fast enough. Alright, so what I'm gonna do, I'm gonna move some of these libraries right now, which are on my active 4K, work 4K drive right there. We're gonna move it over and copy. This is my latest project with HomePod. So what I'm gonna do, I'm gonna copy it over to my drive, which is on the NAS. File, copy to library, active on NAS. And let's see how much time it will take. Yeah, we're gonna move pretty much everything. So let's go and move it up. And at the same time, while it's moving, you're gonna see what is the performance on the NAS itself. And this is what we would be interested in. So let's go and check not bond 1, bond 5. And we're talking about movement of 125 megabyte per second. I file over my project over to the active on NAS storage, and I don't see any problem skimming around this file. So there is no delays, so if you click play, it will play
working through the NAS with this particular project. It's not very complicated project, but I have some coloring and some other things, effects and so on, but it's not that bad. So let's see what we have on actual NAS, how much throughput we got. So when the project is playing, I'm talking about 41 megabyte per second. So that's not much, and I see like 10 gig interface is quite enough to work with this NAS without any issues. And as you can see, cache is being used as well, but other than that, there is no problem. So let's see how much time it will take to compile the project on this, and that will be a very good test as well. So this is the actual project, and we're gonna save it and export it. So this is gonna go to the file, and I'm gonna locate the file on my export directory. So meaning that it will use NAS as a source, but it will export back to the actual disk on 4K right over here on my storage, which I'm using it for originally. Location would be 4K on my RAID array, and then just go and export it. Let's see how we're doing here. We're reading at 62 megas, roughly 70 megasecond, and still climbing.
A few moments later.
Alright, so it's done. Roughly 9 minutes and 15 seconds. Same thing again, just export this time to normal drive. Right now data will go from NAS back to the NAS, just to different set of drives.
A few moments later.
And the result for this run is 11 minutes and 22 seconds. Alright, so this is export from location on the RAID array, which is SSD, original location, to itself.
Alright guys, so what are the conclusions for this video? Basically what I see is you can work with 10 gigabit link connection to Synology and still has no issues you working with FinalCut Pro footage, but it's probably advisable to have at least 4 drives in your Synology RAID array on RAID 5 in order to get specific speeds and make sure you have enough throughput provided by the disk, because the link is okay, but the throughput on the disk is not. As you can see here, the data is showing up numbers which basically from the compilation perspective there are a couple minutes difference between my Synology NAS provided RAID array and also the numbers which I'm getting from Akitio. So they're pretty close by comparison, but from the protection wise, Synology disk array is capable of holding more disks and total amount of storage will be much more. Also, it's a good thing to get this all the library and all your footage from the previous projects available for your immediate use if you work on a project. The same would be true for the photo libraries. If you have a lot of pictures, you can operate directly on Synology disks using this particular setup. As usual, I will put all the links to the products which are featured in this video in the comments section down below, so you can review those and purchase them if you really like them. These are not affiliated links, so just if you really need this, this will make your search on these products much easier. Okay, so that's it for today's review. I hope you enjoy it and I hope you like it and it's useful for you, and I wish you all the best in the new year, and I'll see you around next time. So for now, just please subscribe, that will means a lot to me. Share this video with your friends, and make sure your notification bell is on, so when we create new video on this channel you will be automatically notified directly in person that there is a new video waiting for you on this channel. Until next time, I'll see you around. Peace.